Hello and welcome to the UIL Fall 2020 Student Activities Conference, virtual edition. My name is David Trussell. I'm Director of STEM Activities for UIL, which includes our competitions in robotics, math and science, and the topic for today's presentation, which is our computer science contest. With us today is Dr. Shyamal Mitra, who has been a valuable member of our UIL State Computer Science team for more than 10 years. Is also a professor of computer science at the University of Texas at Austin, and will have some great information to share with you in this presentation. And so we'll hand it over to Shyamal. And Shyamal, as students are thinking about participating in UIL Computer Science, how should they approach preparing for the contest?
Thank you, David, for that introduction. And that is a great question. And I think that's a question that is on the minds of every student and every coach that is participating in the UIL computer science contest. For my own part, I would like every student to set their goals high and prepare for the contest as if they are planning to go to the state contest in computer science. The discussion that follows is a very systematic approach to training oneself. And the first thing that you should know is the structure of the CS contest and the rules. And we have a video already that covers the structure of the contest and the rules. And then the next place that you want to go to is the UIL academics page. And I have a link here that I'm going to go to right now. And I click on this link and it takes me to the academics page. I go down to STEM and there is computer science, and it brings me here to this page. So it has a lot of great information. And what I want you to do is download the topics list, the current topics list. And let me do that right now. Here is the current topics list, and you should be familiar with that topic list. But what you should note is there's a second page to that topics list. And here are the first 15 questions. It's always going to be in that order. And those are the 15 questions that you should all get right or correct. And the last two questions are free response, and just be aware of it. Let me now go back and talk about the structure of Java, the basic syntax of Java. So the topics list actually covers a lot of topics, but it is not in the order that you should be studying. Here is an outline of the order or topics that makes a lot of sense. The very first question in the written test in UIL is an arithmetic question that involves arithmetic in binary, octal, or hexadecimal notation. So you want to make sure that you get that question right, because it involves just addition or subtraction in those notation form. Then once you get started in learning Java, the first thing that you have to do is write the Hello World program. And that is true for any language that you are studying. You write the Hello World program and make sure that it is running on your system. That's just to make sure that everything is working properly on your system. Learning a language, a computer language, is like learning a natural language like English or Spanish or French or Russian. You start with the character set, and the character set is basically the alphabet of the language. And for a long time, it was ASCII. It was 7 bits, and it was basically the letters of the English alphabet. And then when other countries started programming, they wanted their languages to be included. And so now we have Unicode. And Java, every character is Unicode. You don't have to know Unicode. Just remember that ASCII is a subset of Unicode. So think of the character set as being the alphabet of a computer language. And then what do you do after you learn the alphabet? You make words. Well, excepting we don't call them words, we call them variables. And there are certain rules that you have to know about creating variables in Java. And then you have words in a natural language that describe nouns. So we also have words in a computer language that describe variables. In a natural language, we call those words that describe nouns adjectives. In a computer language, we call them types. And Java is a very strongly typed language. What that means that every variable that you create has a type attached to it. Some types are primitive types. They are given to you by Java. Sometimes some types are reference types that you create or are provided to you by Java, the framework. So now that you know words, creating words in Java, what do you do next? Well, you write simple sentences. Well, the equivalent of simple sentences, we don't call them sentences, we call them statements. And when you were learning English, you learned that you had sentences and then you had phrases, and the phrase could not stand by itself. It had to be part of a sentence. And we have exactly that same concept in a computer language. We have expressions that cannot stand by themselves, and we have statements that do, and expressions have to be part of statements. So think of a statement as being a very simple sentence. And now the simplest of those statements is an assignment statement. It is the natural language equivalent of the conjugation of the verb to be. I am, you are, he is. And so you have a simple assignment statement that goes as X is equal to 2. So we start with that. Then you have to progress beyond simple assignment statements, and in a natural language, you have parts of speech. In a computer language, you don't call them parts of speech, we call them operators. And there are exactly 5 classes of operators. Arithmetic operators, and you know all those: addition, subtraction, multiplication, division, and then the modulo operation. And then we have 2 more, which is the increment and the decrement operators. And the increment operators adds 1 to a variable. Decrement operator subtracts 1 from the variable. And then you have comparison operators. You compare one thing with another. And in no particular order, it is less than, equal to, greater than, equal to, and not equal to. And when you apply a comparison operator, the result is always going to be a Boolean. That means it's going to be either true or false, which leads to the next class of operators, which are Boolean operators. And we have 3 of those: not, and or. And this forms a complete set. What it means when I say a complete set is that you can express any Boolean expression with just those 3 operators. You don't need anything else. And then for historical reasons, we have 2 more operators: bitwise and shift. And this is when you go down to the bit level and you're dealing with the ones and zeros. And you have and, or, not, XOR. And with the shift, you have shift to the left, shift to the right. After you've covered the operators, which is the computer language equivalent of parts of speech, you go into conditionals. Think of conditionals as making sentences that have clauses in them. If, else. If something is true, do this, else do that. And then Java throws in a switch statement, which is a nested if else. And then you have loops. And what is a loop? A loop is a body of code that is repeated several times. And Java gives you several ways of writing your loops: while, for, do while, for each. After you have covered loops, you are ready to do something more. If you were doing a natural language, this is the time your teacher would come and say, write a paragraph. And we have exactly that concept in a computer language, excepting we don't call it that a paragraph, we call that a method. And there are several types of methods that are available: built-in methods, then methods that come in libraries like the math library, the string library, and then most importantly, user-defined methods. These are the methods that you write. And we have libraries that I just mentioned a little while ago: math library, string library, the random library, that you would import and use methods from those libraries. Now, there's something that we do in a computer language that we normally don't do in a natural language. We have to store values. You have to store values. Remember, when in a natural language, if I were introduced to you, I would store your name in my memory implicitly. But in a computer language, I have to explicitly store the values in memory. And the way I do it is using arrays. And in our contest, you're going to be responsible for 1D arrays and one-dimensional arrays and two-dimensional arrays. Then there's another thing that we do in a computer language that we normally wouldn't do in a natural language, and that is input and output. Because I'm talking to the computer, I need to send data to the computer, and the computer does the computation and gives me back the result. And there are basically two ways in which I can do it: on the console, which means I'm typing things on the keyboard and seeing the result on the monitor, or I'm reading things from a file and writing things to a file. David, this covers the basic syntax of Java, and students are ready for something else.
So now that students have the basic syntax down, what should they do next?
You know, what they should do next is they should be programming. I mean, I strongly recommend that they should be programming as they are learning the syntax. That's one of the best ways to learn any computer language. And the equivalent of that would be, how do you learn how to swim? Well, you could watch videos on swimming, but that's not going to help you. The best way of learning how to swim is to jump into the water. And that's how you learn how to program. And I would say start with CodingBat, because CodingBat has some great exercises. They're short, they're simple, and I would really want you to get started on that. Next, I would go to Geeks for Geeks. This site has got a wealth of information. First, it has syntax of Java, which we just covered. It has algorithms. It has got data structures. And if you scroll down, it has even puzzles and quizzes. So this is a great place for you to do some substantial programming. Then there's another site called LeetCode. And LeetCode is similar to Geeks for Geeks. They also have lots of questions. Here is one. It says there is 1,700 questions for you to practice. The great thing about this site is even tells you the difficulty level. I would start with the easy ones and then go on to the medium difficult and then to the hard ones. And these are graded just the way it is done in Coding Bat. So these are 3 great sites for you to work on. Let me go back to my site. And the next topic that you should be getting into is object-oriented programming. Object-oriented programming is necessary for your written contest. It is also important, but not essential for your programming. There are 4 main principles of object-oriented programming, and that's abstraction, encapsulation, inheritance, and polymorphism. And if these terms sound strange to you, and it's natural that it does sound strange, there are some wonderful tutorials that will get you started. Here is one, object-oriented programming. This is the official site that goes through the what I just talked about. What is an object? What is a class? What is inheritance? And then here it goes into more depth, talking about classes, objects, nested classes, and enumerated types. And finally, you have the interfaces and inheritance. Interfaces allow you to do polymorphism, and then you have the other concept of inheritance, which is a primary structure in object-oriented programming. I think this covers some of the more important topics that go beyond basic syntax, David.
So what are some of the more difficult types of questions that students might encounter on the computer science written tests?
You know, so let's go to the extreme. Let's ask, what is the most difficult question that they're going to see on the written test? And I think, in my opinion, the most difficult question that they're going to see on the written test is tracing recursive code. And recursion is going to be very important also in the programming, because there's always going to be some programming question that involves recursion and then could not solve the program without doing recursion. And I have some great sites for you to look at. Here is the MIT reading on recursion. This is a beautiful site. It spells out recursion. It gives you how recursion takes place and how to decompose a problem in recursion. What is the structure of recursive implementation? How do I write helper methods that are recursive? And then choosing the right recursive subproblems. It's a great place to start. And I'm going to show you some more. How about tracing recursive code, that which I said was extremely difficult? And here is a site that lets you do that. This is it's a short course in Coursera. It is free. And it talks about inheritance and recursion, but the more important thing is the tracing of the recursive code. And this particular program does that very, very well. Then finally, I want to show you another great site. And this is my absolute favorite site. I have to tell you that. This is a site from Princeton. This is by Robert Sedgwick, who I think is one of the best instructors that we have now in teaching computer science. And he has a section on recursion. It builds from a very small, starts from building very small recursive functions. and it goes all the way into some extremely difficult recursive code. But he does not just leave you there. He gives you lots of problems. Let me show you some of those. Here is the problem set that he starts. Web exercises, starts with doing Euclid.java, and then goes all the way down, and you have lots of great problems here. And we have something like the order of 60 or so problems. So this is this, and I'm sure if you could do even a subset of this problem, these would be wonderful for doing recursion. After you've done recursion, there's another area in computing science that I think you should all master, and that is basic algorithms in sorting, searching, and merging. And you're bound to see questions on those. You're bound to see questions. I have two links, one which shows you how to visualize sorting algorithms. It does not give you the code, but it's a great start. Talks about insertion sort, selection sort, bubble sort, quick sort, merge sort, and those are some of the sorts that you're responsible for. And then some searching algorithms. And the one in particular that I want you to know very well is binary search. Binary search. So this will cover most of your sorting and searching. And now you want to go into data structures. And data structures that you are going to be tested on are stacks, queues, linked lists, binary search trees, heaps, and graphs. And I have some resources for you. Here is a tutorial on data structures in Geeks for Geeks. It covers all of the things that I just mentioned. Then there are these two courses, Data Structures and Algorithms on Coursera. They're free, and it covers everything that you need. And this is again from Princeton University. This is the algorithms part 1, and then they have a follow-up class to this, which is algorithms part 2, and it covers all of the data structures that you need. But you need to make sense of the algorithms that you're learning, and you need to put these algorithms in bins. And there are 4 bins that you put these algorithms into: brute force, greedy, divide and conquer, and dynamic programming. And here is a brief discussion of those 4 methods. Brute force. You're going to try brute force, sometimes it's called exhaustive search. You're going to try every possibility, every permutation, every combination. Sometimes you have to do it. What's the downside of brute force? The downside of brute force is that it takes a very long time. And then you have greedy algorithms, and greedy is when you're lazy. And when you're lazy, you want to just make, you want to look at the local maximum or the local minimum. And you're satisfied with a good solution, maybe not the best solution. And greedy will help you there. And you need to know how to do a greedy solution. And then you have divide and conquer. And recursion actually falls under the general umbrella of divide and conquer. And how do you divide and conquer? Well, merge sort is a great example of that. Let's say I have a pile of things I have to sort, and I look at the pile and say, this is too big. How will I sort this pile? Well, I'm going to divide that pile into 2 halves, and I'm going to sort one half, and I'm going to sort the other half, and I'm then going to merge the 2. So I have this half of a pile. What do I do with it? And I do exactly the same. I divide it into half, and I sort one half, and I sort the other half, and then I merge the 2. And then I take the smaller pile and I do exactly the same. Divide it into half, sort one half, sort the other half, merge the two. When does this division stop? Well, when I am down to one element. And then I work backwards until my whole pile is sorted. That is what divide and conquer means. And recursion is a part of divide and conquer. And then finally, we have dynamic programming. Dynamic programming is a great approach to programming, but it only solves what we call extremum problems. That is, problems that deal with maximum or minimum. And it does work for some very simple problems, like getting the coefficients of the binomial expansion a plus b to the power n. And what we have is Pascal's triangle. When n is equal to 0, the coefficient is 1. When n is equal to 1, it is a plus b. So the coefficients are 1 and 1. When n is equal to 2, it is a plus b whole square. It is a square plus 2ab plus b square. And so the coefficients are 1, 2, and 1, and so on. And you notice how the triangle is built up. It's built up starting at n equal to 0, going to n equal to 1, n equal to 2, n equal to 3, and so on. If you think of divide and conquer as a top-down approach, you start with the big problem and you break it up into a smaller problem. And then you take the smaller problem and you break it into a yet smaller problem, and so on. Dynamic programming is just the opposite. Start at the smallest problem and you build until you reach the original problem. And it's a great approach. And again, you will have to master this approach. I think, David, this covers almost all that they would need for their programming.
Are there topics that you haven't covered that would be important for the students to know?
Yes, there are some topics which I did not cover, and they will come most likely in the written test. One of them is regular expressions, and once again, here is a tutorial. It's an exhaustive tutorial that will cover anything that you needed to know about regular expression, and this is from the official Java site. And the other is lambda expressions, and here is a tutorial on that. More importantly, after you go through the tutorial, what you want to do is go back to CodingBat, the site that you started from, and what you notice that they have functional programming 1 and 2, and they use lambdas in those. And so this gives you very good practice with doing with lambda. And the UIL site also has a sheet on lambda expressions. And I think, David, this covers most of the topics that a student should know.
So what should a student do who wants to go beyond the UIL Computer Science contest, who might be interested in pursuing a career in computer science?
That is a great question, and I'm sure that there are lots of students who want to make computer science their choice of career. The first thing is that here is this training site for the USA Computing Olympiad. Here is a training place that they can sign up, and this is excellent, absolutely excellent. But you can only start on this after you have mastered the basic syntax, the basic data structures. It assumes that you know all of that. And then you also have practice problems on Catus. Strange name, and there's a little cat there, but Catus is the official platform on which the international programming contest takes place. And they have a whole database of problems. And they have a difficulty level associated with it. I can click on the difficulty, and there it is. It is graded according to difficulty in ascending order. So you can start with the easy problems first and work yourself towards the more difficult problems. And there are enough problems to last you a lifetime. So Catus is another great site that will prepare you. I'm also thinking of the ACM site, and I have the last link there, which are the ACM challenge problems. And here it is. Browse problems on the ACM website. And it is in different folders. There are about 10,000 problems there. 10,000 problems. I mean, it will take you several lifetimes to even go through and do and try them out. I think this is a good start. This is a good start for students, what we have listed, and it is a start. It's a way for students to prepare themselves for the contest, prepare themselves for a career. But David, I want you to remind us, what is the benefit of going to the state contest?
Well, thank you, Shyamal. Yes, there are definitely great benefits to participating in UIL Computer Science, and of course, advancing to state. Looks great on your resume. You get an opportunity to meet other students, not only from your own area, but throughout the state of Texas, who also share your interest in computer science. And there are some great scholarship opportunities. If you advance to state at any point during your high school career, you become eligible to apply for Texas Interscholastic League Foundation scholarships. The TILF is a great scholarship program that's been around since the 1950s, awards millions of dollars worth of scholarships, and the main criteria to be eligible for those is to advance to UIL Academic State Meet at some point during your high school career. And that gives you access to apply for dozens of different scholarships through a single application process. So it's a great opportunity. So thank you, Shyamal, for lots of great information. We have, in addition to this video, another video with the conference that goes into some of the basic contest structures. So if you're new to the contest, or if you just need a refresher on some of those basic rules and processes, you might want to check out that video as well. And we have a handout page where we have slides and links and other information posted as well. And you can find all of that on our UIL conference webpage with links to the other videos and handouts as well. Thank you for joining us for this presentation, and best of luck in this year's competitions.
Thank you.